Okay, this is this is a very important lesson this right now because I'm going to teach you something how to use your calculator that will become very beneficial to you in this chapter and future chapters and what have you, especially this chapter. When you're multiplying to, oh, let's just first look at the question. I've got 3 red, 4 yellow, 6 green, so a total of 13 marbles. If I draw a marble and replaced, that's a big difference. We'll get to that in a minute. Whether it's replaced or not, what the math is. What is the probability of drawing a red, then a green? We multiply the probability of red, which is 3 out of 13 because there's 13 total, and times the probability of drawing a green, 6 out of 13, okay? And this stays 13 because I put it back in, okay? Put it back in, so this denominator is still 13, 6 out of 13. Now, here's the important part I want to stress. On your calculator, basically if it's a numerator, you multiply, and if it's a denominator, you divide. And you could do this all in one step real quick. I'll go 3 times 6 divided by 13 equals. That's exactly how I put it in my calculator, okay? 3 times 6 divided by 13 equals. In other words, if it's in a numerator, it's a multiply, and if it's in the denominator, it's a divide. And if you do that, 3 times 6 divided by 13, you never have to hit equal until the very end. There's your answer. Second part, blue, 4 blue, 6 green, 13 again. Draw blue and then a yellow. It does not say it's replaced, does it? Up here it says it's replaced. If it doesn't say it's replaced, it's not replaced, okay? I mean, they're not going to tell you every time it's not replaced or is replaced. You know if it is replaced or not, okay? So then I will, okay, so now that it is replaced, so there's 4 blue, right? Okay, so it's 4 out of 13. Now there's 1 less marble, okay, because it's not replaced. And there's 3 yellows, so now my probability is 3 out of 12 instead of 13. And again, make your life easy. Calculator, 4 times 3 divided by 13 divided by 12 equals. Just put it in just as I just wrote it and said it. 4 times 3 divided by 13 divided by 12 equals. And there's your answer. Okay, when they say pull 2 marbles out at the same time, you kind of have to think of it as pulling one out and then pulling another one out without replacing. That's in your head. That's how you have to calculate it, okay? Because that's exactly what you're doing. If you break it up, that's exactly what you're doing as far as the math goes, okay? So there's 31 total, so it's 11 over 31, and there's 1 less marble after the first one, and 10 out of 30, okay? They want that as a reduced fraction, so we'll make this a different color. And a reduced fraction, that's 10 over 30. It reduces to 1 over 3, so your answer is 11 divided by 93. Now, if they want a fraction, your multiplication, division stuff that I told you before, it's invalid because they want it as a fraction. So if they want it as a fraction, you just have to go ahead and break it down and put it as a reduced fraction, okay? I wonder, they might take this, if they don't tell you, let me see if they'll take that, 11 divided by 93. Let's see if it'll take either. Sometimes they'll take either or. So 11 divided by 93 is 0.1183. 0.1183. Submit, let's see. Yeah, it looks like it'll take either one. So you could do it as a fraction or, and again, if we were doing that, how I just told you before, it would be 11 times 10 divided by 31 divided by 30 equals. So this one, we can go, if they want it as a fraction, you do it what I told you, but this one will take a decimal too, so it would be 11 over 31 times 10. You don't need to reduce it if you're doing a decimal. You don't need to reduce anything if you're doing a decimal. Don't bother. Okay, you could, but it won't matter. You just may as well just run it out. Okay, 11 times 10 divided by 31 divided by 30 equals 0.1183. Okay, there's sampling. There's 1,350 CDs total, and 60 of them are defective, okay? If 3 of these are randomly selected, what is the probability that the entire batch will be accepted? In other words, what's the probability that all 3 will be good to go? not defective. Well, if 1350 total and 60 are defective, then you mean take 1350 minus 60, 1290 of them are good, okay, out of 1350. So the probability of getting the first one is 1290 divided by 1350, okay? Now we have one less CD and one less good one, okay? So then what's the probability after I draw the first one that the next one is good? So it's one less be 1289, one less be 1349, okay? After I draw the first two, what's the probability of the third one being good to go? So one less good one, which is 1288, one less total, which is 1348. And again, I highly encourage you to do it as I said. So 1290 times 1289 times 1288 divided by 1350 divided by 1349 divided by 1348 equals, boom. Okay, I've got 19 marbles, 8 red. What is the probability I draw 3 red, then they're all red? Well, there's 8 marbles. Probability I draw the first one, red, is 8 out of 19. One less of each times 7 out of 18. One less of each times 6 out of 17. And again, it's 8 times 7 times 6 divided by 19 divided by 18 divided by 17 equals that. For none of them, well, if 8 of them are red, that means 11 of them are not red. So do the same thing and start with 11. 11 over 19 times 10 over 18 times 9 over 17. You get that. Okay, the first thing you want to do is total all of the people. And if you total 52, 244, 79, and 608, you get 983, okay? First thing you do. What is the probability that they both, if you draw 2 people, okay, that's a total of 689. I'm going to erase that and put it down below, 689, so you can see. So the total of no is 689, okay? 79 and 608, all right? Or 687, rather. All right, so if the total no's are 687, the probability both involved were not intoxicated. The probability pedestrian, 2 different pedestrian deaths, so these are pedestrians here, were not intoxicated. So there are 687 total pedestrians were not intoxicated. So then you multiply 687, you do 687 over 983 first, that's some probability if I select 1. Now there's 1 less of each times 686 over 982. And you get that. 687 times 686 divided by 983 divided by 982 equals. Okay, I've got 9 chocolate, 8 peanut, 8 sugar, 8 oatmeal. Okay, probability I go in and grab a chocolate chip is 9 out of 33. And then I eat it, which means there's 1 less chocolate chip in the bag and 1 less total in the bag. But now I'm going in, and what's the probability after that I reach a peanut butter cookie? Well, there's still all 8 peanut butter cookies left, but there's 1 less total. So you multiply that times 8 over 32. Okay, you got first as a club, second as a heart, don't replace. So the probability of a club is 13 out of 52. I still have all my hearts, which are 13, but I have 1 less card in the deck, so times 13 out of 51. It's 13 times 13 divided by 52 divided by 51 equals 0.0637. Okay, this is a fun one. They do ask you to put this as reduced fractions, so I'm going to remind you how to reduce a bunch of fractions. So first of all, there's 35 capacitors, 5 are defective. What's the probability I get them all defective? First one is 5 out of 35, 1 less of each, 4 out of 34, 1 less of each, 3 out of 33. 1 less of each, 2 out of 32, 1 less of each, 1 out of 31. Multiply them all together. Here comes the fun part. Let's change color here to red. 5, then we just start reducing anything that goes in on the top and on the bottom. So 5 goes into 35 7 times, so that's 1 here and 7 here. 4, you could divide top and bottom by 2. 4 divided by 2 is 2, and 34 divided by 2 is 17. 3 goes into 33 3 times, so I could go 1 here, and I could go 3 here. 2 goes into 32 16 times, so I could go 1 here, and I could go 16 here, and I can't do anything there. Now I could do 1 more. I'll just change that color to blue, say. 2 goes into 16. It doesn't have to be on top of each other. This 2, 1, goes into 16 8 times, okay? So now I just multiply the numerators together. 1 times 1 times 1 times 1 times 1. It just happens to be 1. It's not always like that. And then if I go, then I multiply 7 times 17 times 3 times 8 times 31. And I get this answer here. So 1, if I multiply all those together, I get 324, 632, which is the denominator. Okay? All right, let's try it again for this one. The same thing. Now, what are the probability that none of them are defective? Well, there's 30 out of 35 that aren't defective. And then I do the same thing. 1 less, 1 less, 1 less, 1 less. Okay? So a 30 and a 35, let's see. They're both divisible by 5. So 30 divided by 5 is 6. 35 divided by 5 is 7. That doesn't go, nothing goes there. 28 does, but there's 28 and 34. Those are both divisible by 2. So I could go 28 divided by 2 is 14. And 34 divided by 2 is 17. Okay, anything up top with anything on bottom. Okay, and let's see, 14 and the 32, so I could divide both of those two by 2 again. So I'm going to take that 14 and make it 2, and I'm going to make that 16. Oh, I could actually, or not 2, 7. So 14 divided by 2 is 7. Could easily screw this up, okay, out of 16. And 27 and 33, 3 goes into both. So 27 divided by 3 is 9, and 33 divided by 3 is 11. Can I do anything else? I don't think so, but let me look. Never know. Well, let's multiply the numerators, see if I get 10179. So 6 times 29 times 7 times 9 times 26. Nope. Hold on. I'll be right back. Okay, this 7 cancels with that 7. 1 here, 1 here. So that one got canceled 3 times. I can divide both of these by 2. So this would be 16 divided by 2 is 8. And 26 divided by 2 is 13. Okay, there's a 6 and an 8 here, so they both are divisible by 2. 6 divided by 2 is 3, and 8 divided by 2 is 4. This is getting really messy. Okay, got it. All right, so that's it. I just checked it. I paused it and checked it. So it's 3 times 29. So let me change colors here. What color do you want? Yeah, let's go with black. All right. 3 times 29 times 1 times 9 times 13 equals 10, 179, and 1 times 17 times 11 times 4 times 31 is 23188. Pain in the butt, but you could do it. Okay, 3 cards from our deck, all are queens. There's 4 queens, so it's 4 out of 52 times 3 out of 51 times 2 out of 50. And of course, they want it as a reduced fraction. 2 out of 50 is 1 out of 25. 4 out of 52 is 1 out of 3. 3's cancel out. 1 here, 1 here. So the answer is 1 times 1 times 1 equals 1. And hopefully 51 times 25 is their answer there. 51 times 25. It is not. Oh, made an error right there. Sorry. 1, disregard 1 out of 4, not 1 out of 3. 4 out of 52 is 1 out of 13 rather. My brain's starting to lose it. Need a break. Okay. So 4 out of 52 is 1 out of 13. Okay. And then 1 out of 25. Okay, and 3 goes into 51 17 times, so 1 here and 17 here. So now, hopefully we get the right answer. So 13 times 17 times 25. There you go. It's 1 out of 55, 25. I'm going to multiply 13 times 17 times 25 together. That goes here in the denominator.